Let us discuss two problems in this class regarding the measurement of pressure using manometers. The first problem is the figure is given like this. There are two pipes. So in the first pipe you have a liquid of specific gravity 1.6 is flowing. In the second pipe a oil of specific gravity 0.8 is flowing. So these two pipes are running in parallel like this, and they are connected by a U-tube differential manometer which contains mercury. So here the thing is, he has given the elevations. So the elevation difference between the first pipe center and the second pipe center is 2.5 meter, and the elevation difference between the first pipe center and the mercury level in the limb connected to the first pipe is 4 meters, and the difference in the mercury level between the two limbs is taken as h here. Now the question here is, we have to find out the value of this h, that is deflection of mercury in the manometer. He has given the pressures at A and B. Pressure at A is 105 kilopascal and pressure at B is 175 kilopascal. So he has given the pressures at 2 points, and he has asked the value of the deflection of mercury level in the manometer. So this problem can be solved by writing the gauge equation in terms of meters of water, which I have explained in the earlier video. So let us start from this first point A, then the next point is C, then it is D, then it is B. So first we will take the pressure at point A. It is PA by gamma W in terms of water, plus because C is below A, pressure at C is more than pressure at A, therefore it is plus. The elevation difference is 4 meters multiplied by the specific gravity of the liquid which is contained between A and C, which is 1.6. So 4 into 1.6. Then the next point is D. So the elevation difference is h here, and the specific gravity of mercury is 13.6. So h into 13.6. Then next point is B. Here B is above D. That means we have to take minus sign here, because the pressure at B is less than pressure at D, and this elevation difference we have to take now. This elevation difference is, according to this sketch, 4 plus h minus 2.5. So 4 plus h minus 2.5 is the elevation difference between the points D and B that we have to write into whatever specific gravity of the liquid is there between D and B, which is 0.8 here. So so 0.8. And now we have come to point B. So the pressure at B is equal to PB by gamma W. So this is how we have to write the equation. So the first term only gives the pressure at A. First and second gives the pressure at C. First, second, third, this gives the pressure at D. First, second, third and fourth, it will give the pressure at B. So this is how we have to write down. Now after writing the gauge equation in terms of meters of water, just go on substitute the whatever values you know in the given problem. You go on substitute and find out the unknown. Here h is the unknown. Now the pressure at A he has given 105 kilopascal. So we have to convert that into pascal or Newton per meter square, because whenever you are using a gauge equation, the units you should be very careful. Newton and meter we have to use. They are the units. Whatever may be the units given in the problem, you have to convert pressure to Newton per meter square and elevations in terms of meters. Now if you simplify the substitute and simplify, so PA is 105 into 10 power 3 Newton per meter square divided by gamma W value you know 9810 Newton per meter cube. So this is standard value, you should know that value. Then if you simplify this, plus 4 into 1.6 is 6.4 plus 13.6 times h, minus if you simplify here, it becomes 1.5 into 0.8 becomes 1.2, and minus 0.8 h is equal to, here PB has given it as 175 into 10 power 3 divided by 9810 is gamma W. Now here the unknown is h. So if you simplify the equation and if you solve for H you are going to get 0.152 meters. It will be in terms of meters. So meters of mercury, because the manometric liquid which is used here is mercury, 0.152 meters of mercury, or it can be written as 152 millimeters of mercury. So that is the deflection in the mercury level in the manometer. So this is how we have to do the problem using manometers. So gauge equation is very, very important. While you are writing the gauge equation, write it in terms of meters of water. Units you should be careful. Units should be in Newton and meters only. Now the second problem, it is regarding to a U-tube differential manometer or gauge. It is attached to two sections, A and B, in a horizontal pipe. So figure is not given. In this problem, this is an examination problem, figure is not given. You have to draw the figure. Here figure is given, but in this problem figure is not given. So it is a horizontal pipe like this. It is a horizontal pipe. There are 2 points in the pipe A and B. So here manometer is connected between these 2 points A and B. I have shown here. This is the U-tube differential manometer. So the thing is, what he has given here is water is flowing in this pipe, horizontal pipe. Therefore, specific gravity of water is 1. That you know. So calculate the mercury level difference in the manometer when the pressure at A is 70 kPa. So please note here, also that H is unknown here. So pressure at A is more here, pressure at B is less here. Because that you can observe by knowing the mercury levels here. If the mercury level is below, then the pressure at that point is more, because water exerts more pressure here compared to this point. So here the pressure at A he has given PA value, he has given 70 kilopascal, or it is 70 into 10 power 3 pascals or Newton per meter square. But what he has given here is the pressure at B, pressure head, instead of giving pressure, he has given pressure head at B as 150 millimeters of mercury. So instead of giving in pascals or kilopascals, he has given in the form of millimeters of mercury. So we should be very careful when such types of problems are given. We have to convert this millimeters of mercury to Newton per meter square of water. So that is very, very important. That's why I have taken this problem. So PB 150 millimeters of mercury, that means it is 0.15 meters of mercury. So from mercury you have to convert it to water. Very, very important, because PA is in terms of water. Water is the flowing fluid. So therefore this mercury pressure we have to convert in terms of water pressure, that too in Newton per meter square. How to do that? First we will convert this meters of mercury to meters of water by multiplying it by 13.6, which is nothing but the specific gravity of mercury. You are going to get in meters of water, then that becomes 2.04 meters of water. When that 2.04 is multiplied by density of water, you are going to get in Newton per meter square. These things I have explained in the earlier videos also. You can just go through that once again. So this is the pressure at B in terms of Newton per meter square of water. So this is PA, this is PB. So when you are writing the gauge equation, these values you have to consider. You have to substitute these values. Now this is the diagram similar to the earlier problem. So the difference is here there are 2 pipes and 2 different liquids are flowing. Here is a single pipe, only water is flowing. So now gauge equation let us write in terms of meters of water. So you have to start from this point A. So pressure at here in terms of meters of water is PA by gamma W. Then as usual the elevation difference we will assume it as X here. So it is not given, it is not required also. Let us write it as X. So X into specific gravity of the liquid. So from A to C, the liquid is water, specific gravity is 1. So X into 1. Plus because C is below A. Then comes D. D is above C. Since D is above C, you have to take minus. Very important, because pressure at D is less than pressure at C. So it becomes minus. So difference in elevation is H, and the specific gravity of the liquid, it is mercury, it is 13.6. Even if they don't give, so you have to take it as 13.6. Please remember this. So for water it is 1, specific gravity is 1. For mercury it is 13.6. For any other liquid, they will give the value. So these values you should remember. So this becomes minus h into 13.6. Then once again next point is B. B is above D. That means pressure at B is less than pressure at D. So you have to take minus sign. So difference in elevation between D and B is, from the diagram you can see that here it is. This is h. This is h. This is x. This is h. This becomes x minus h. So minus x minus h, and the liquid from D to B is water once again. So that is 1. So similarity is 1 is equal to, now you are at the point B, is equal to PV by gamma W. So this is the gauge equation. The first term gives the pressure at A only. First and second together gives the pressure at C. First, second, third gives the pressure at D. First, second, third, fourth gives the pressure at B. That is why it is given as PB by gamma W. So it is within the pipe only. Therefore, there will be some value for PB. Whereas in the case of simple manometer and single column manometer, which I had explained in the last video, the last point was exposed to atmosphere. So atmospheric pressure is taken as datum, and it was taken as 0 here. There is 0 there. But here, since A and B, they are within the pipe, so some pressure exists. Now, once you write the gauge equation, substitute the values in Newton and meters, so and simplify and get the unknown. So PA is given is 70,000. 70 into 10 cube means 70,000 Newton per meter square. This is the unit, and this is of course same. Specific weight of water 9,910 Newton per meter cube. Then plus x into 1 is x minus 13.6 h minus x plus h is equal to PB is this value actually. Please note, this is very important. So we have to convert 150 millimeters of mercury to Newton per meter square of water, because both the pressures should be in same units and with respect to same fluid. That is very important. Now, if you simplify this equation and solve, you are going to get h as 0.4040 meters of mercury. So because this value is mercury, the deflection in mercury levels, therefore it gives in meters. The whatever value of h you are going to get, it will be in meters. Then you can convert that into millimeters by multiply by 1000. So 404.4 millimeters of mercury. It is the deflection of mercury level in the manometer. In the laboratories, of course, scales will be provided. Scales will be provided to measure this mercury levels. So it will be something like this. The scales will be provided. So we are interested in finding this difference by reading the scale in centimeters or millimeters. Later on we can convert that into meters and do the problem. So this is how we can analyze the problems using differential manometers, wherein you may require the difference in pressure, or you may have to find the deflection in the manometric fluid normally, which is mercury. Mercury is mainly used because, as I already told, you can measure larger pressure differences by having a smaller deflection in the mercury level. Since it has got a higher value of specific gravity, and also it won't mix with other fluids. So that is the reason why mercury, and it has got a value of very high vapor pressure. So these are the reasons why mercury is used in manometers as a manometric fluid.